All right, take a look at number 1 and see if you can make your drawing before I do mine. I'm going to help you all with your drawings, but I'd like you to try it first yourself. Got a ladder leaning against the wall. I'm going to put my wall on the right side of my paper. I'm going to draw it kind of small, so you guys can have it on the same side. And then I'm going to lean the ladder against the wall. Do y'all understand why the angle can't be super steep? Look, take a ladder, and you lean it against the wall, and if it's too steep, and you start walking up the ladder, and you look out, whoops. You ever done that before? Rode the ladder down? Oh, I do that a lot. You're up here, and you're working on, for those of you who watched Christmas Vacation or something else, you're working on something, and you push off, well, just a little bit. If your ladder's pretty steep, and you don't have enough of an angle at the base, you go out this way, right? It's really scary. It feels like you're pole vaulting or something. I usually catch myself on something over here, a tree or bushes, whatever.
I don't think bushes are that fun.
No, yeah, but hopefully you land in them, and rather than cement or the sidewalk or something. I've done that too. My son's done that. We all have fun with ladders. Anyway, OSHA, the Occupational Safety and Health Administration, says 70 degrees or less, because it's okay to put in a little more, right? As long as you don't go all the way. Generally, a little more is better than less, right? You want it a little bit less steep, you follow? So 70 degrees is the steepest angle you want to have your ladder at. You don't want to have it more than that, you don't want to have it less. Less is okay, but you don't want to have it more than 70 degrees. But you also want to be able to reach up a ways, right? And there's a huge difference in the price of ladders. If you go from a 12-foot ladder, well, let's say I was just looking at some. If you go from an 8-foot ladder to a 9-foot ladder, the price is doubled. From 8 to 9 feet, the price is almost double. But from 6 to 8 feet, there's almost no difference in price. It's only like a $5 price difference. There's a huge difference in price. So you want to use the shortest ladder you can, right? In general, because it's less expensive and it's safer. It doesn't seem reasonable, but it has to do with the fact that when the ladder gets longer, it has its own weight to contend with besides yours. And it also tends to have different stress points. Anyway, here's your ladder. Set it up. I'll put my wall over here. Wall. Most walls are built at 90-degree angles to the ground. I've seen exceptions to this, but in general. Now I do want a 70-degree angle, and I want to get it at least reasonably close. So I'll just kind of estimate it here real quick. It's about here. Looks like I drew it a little bit too short. I want to get it relatively close to that. So, I'm a little off, but that's okay. There. This is my ladder. And it's 15 feet. And remember, maximum of 70 degrees. We don't want to go any 80 or 90 degrees. Certainly don't want to go 90. And now I'm going to draw my similar triangle. I think I'm going to start with my right angle. Well, 70 is pretty steep. I think it might probably be more like 65. In my 90. Excuse me? What? That's 15 feet long. Yeah. Now, I have a similar triangle here. I know I didn't draw this one to scale. This one is actually 70 degrees. And I'm going to measure my sides. What's that angle at the top, by the way?
30. No, 20.
20 degrees. Yeah, I know. I put the example on the side at about. Anyway, you guys know what to do now. So try number 2, see if you can make your drawings. I'm going to let you do that one on your own. Number 2. I'll help you draw your situation first. Read it first and see if you can imagine, visualize it first. We're looking at number 2, guys. Okay, guys, here's your situation. You're standing on the edge of a canyon wall, looking down. Of course, you're not that big compared to the canyon, but and you have what's called an angle of depression. The angle of depression is what you have to look down at. So you're going from horizontal. It's not drawn to scale at all.
That's dangerous. You're real.
With a rail. Nah. Not if you don't jump. Now we're making an assumption. We're making the assumption that the canyons are actually more or less straight up and down, and they pretty much are. The Grand Canyon is pretty steep, so we're going to go pretty much straight up and down. Sure. This is a right angle. This is called an angle of depression. It's how much you have to look down from horizontal. If you look straight across, you have a 0 degree angle of depression. If you look down, there. Now again, we're assuming that we have a right angle. This is a 65 degree angle. This is about 1,800 feet. And you need to draw your similar triangle. You can draw your similar triangle. I recommend you orient it in the same way. Do y'all know what I mean by orientation? Don't turn it upside down, in other words. Draw your triangle so that it's, this way, like this. And then draw your angle coming down this way so that it's oriented in the same way the other one is. It'll make it much easier, okay? Go ahead and take a look at number 3. Yeah. I just called them ship A and ship B in my first one. Y'all know where Anapra is?
Or what?
What Anapra is? The Naval Academy? Oh, Anyway, navigation has a lot to do. Trigonometry is the basis of almost all navigation on the surface of the Earth. There's a lot of trigonometry used in navigation, as well as in physics and a lot of other areas. So you really need to get this well. How many of you are planning on taking physics or chemistry next year? Anybody? Physics. In physics? Okay. For those of you taking physics, you have to know your trig really well, because you're going to be using it to figure out vectors. Last period I had some trouble. Nobody knew what a lighthouse was.
Last period?
I printed out a lighthouse. It's kind of hard to see, but there it is. I couldn't draw one, so anyway. In case you haven't seen a lighthouse, a couple of pictures here. Okay, I'll send it around in a minute. Let's make our drawing first. Basically, you've got a promontory of land. On it is your lighthouse. Myself some mistakes here.
Is it the house with a lot of light?
Why would that not be one?
Whoa.
Oh, thank you. This is great.
And they usually have a little house for somebody to live at. Directly north of the lighthouse,
What's the art house?
White color.
you have a ship A.
It's an oxymoron.
This is ship A, and at a 40 degree angle from ship A, where this angle is 40 degrees, you have the ship B. Obviously, this is not drawn to scale at all. The idea here is that you want to be able to find distances. This is north, directly north, is straight up on a map, and it's 7.3 nautical miles. We usually call them knots. And we don't know this one. Knots is usually an indication of speed. We usually say the whole word out, nautical miles. But
Wow. Big one.
nautical miles are a little bit longer than a standard mile. Don't ask me why.
Why not?
Why not?